Hello friends, this is Avinash Kore. Welcome to this video. In this video, I'll be giving you a brief introduction about what deep learning is, what are the main factors of deep learning, and what made deep learning so effective, and why is deep learning so huge boom in the current industry as well as in research. So what is deep learning? Deep learning is a specific subset of machine learning, which in turn is a subset of artificial intelligence. Artificial intelligence are any techniques or any algorithms which provide a computer or a machine to mimic the human-like behavior. Similarly, in case of machine learning provides an ability for a system or a computer the ability of a system or computer to replicate a human behavior without explicitly being programmed. Similarly, in case of deep learning is a function or a mapping from a data to a target with some non-linear function approximators. Okay, let's discuss about the timeline of deep learning. It's not that the deep learning has just started from 2012 or 2007 or something, but initial phase research in deep neural networks and artificial intelligence has been started since 1950s. Have been started since 1950s, but only after 2007 there's a huge increase in the research phase of deep learning. The reason being three things. First is big data, hardware and software. What's big data? Due to the availability of the large-scale databases, or basically database management system, cloud computing has enabled the storage of large-scale data and circulate among all the researchers worldwide, which help many research groups to explore this deep learning or data-driven techniques for various algorithms. Hardware. In case of hardware, GPUs are the main thing which scaled up the research or scaled up the research in case of deep learning or in case of any artificial intelligence, which helped us. These GPUs helped us in massive parallelizability. By these GPUs helped in doing lots of millions of calculations per second, thereby allowing us to do a quantitative research in the phase of data-driven modeling. In case of software, many open source softwares like TensorFlow, Keras, Caffe, Theano, and other libraries actually made it open, actually made a deep learning accessible with each and every individual. Okay, why deep learning? Even before deep learning, that's early 1950s, people were still doing object detection and object recognition tasks, but then they were using manually extracted features or hand engineered features. But why deep learning is required when you can manually hand engineer the features? Three things. First, manually hand feature extraction or feature picking up the feature from data is very time consuming process, very expensive process, and in case of hand engineering the feature, each and every individual is restricted by a certain set of features. But in case of deep learning, you are allowing the network to find out its own, find out the feature by its own. This implies that there is no restricted or there is no boundaries for the deep neural networks in terms of feature or type of feature to extract. For example, in case of lower level feature, by lower level I mean that initial layer features look similar to that of the edges, lines, and all these features are in terms of a convolutional neural network feature maps. And mid-level features looks, in case of face recognition, mid-level features look similar to that of eyes, nose, mouth, and many things. And very higher level features implies, by higher level I mean that they are after a certain number of layers, after 10-20 layers, if you see the feature maps, they almost tend to cover up the global information of an image. In this case, they try to encode a face structure in the whole. Okay, how deep learning models look like and how are they comparable with the biological neural networks? Okay, this image, which is in the left of the screen, represents an artificial neural network. This network has one input layer, three hidden layers, and one output layer. In this case, the input information is sent to this network, P's input layer, and then it performs some matrix multiplication and nonlinear operations and then provides an output. In this case, like, this is a kind of a directed graph which can be we can relate this with a biological neural network. Biological neural networks, each and every neuron is connected to every other neuron. There are a lot of analogues which can be drawn from a artificial neural network. Analogues between artificial neural network and biological neural network can be drawn, and that's a separate session in its own. We'll discuss about it in coming videos. So a very basic thing, each neuron which you saw in this model, each neuron is represented as a superposition of all the previous layer information, and this superposition or the activation which is obtained is then passed to a nonlinear activation function. So in this case, in most of the cases it's sigmoid, and there are many other activation functions like PANH, ReLU, and many other things. But the main idea of sigmoid is it gets activated only when the summation is greater than a certain threshold, and we get output y hat. Similarly, in case of biological neural networks, we see x1, x2, x3 up to xn are the input electrical impulses fed to a neuron, and these outputs y1, y2, y3, up to yn is obtained only when the input is greater than a certain threshold. This is method of a sigmoid event. Similarly, there are a lot of analogies which can be drawn from biological neural networks and which are already implemented in artificial neural networks in CNNs or NLP and we'll discuss them in a separate session. Okay, now let's move towards machine learning. Machine learning is a broad area and which has a subcategories like supervised learning, unsupervised learning, reinforcement learning, and all things. In case of deep learning, the supervised learning turns out to be deep supervised learning, unsupervised deep learning, supervised deep learning methods, and deep reinforcement learning methods. What is supervised learning? And if you use a nonlinear curve fitting for supervised data, it becomes a supervised deep learning methods. Okay, what is supervised learning? In case of supervised learning, you give an input data, basically input vector, and you have annotation for that data and consider it to be a target vector, and you expect your network to predict some output, and you measure the output error between the actual target which you already have and then the predicted target, and then we get an error and then backprop this error. Okay, let's discuss about backprop and weight updating rule and all in the later slides. And in a whole, supervised learning is to learn from an annotated data. In case of unsupervised learning, here also you provided the data, but it's not annotated. Basically, you have an input vector, that's it. Basically, the model here tries to draw a inference or tries to calculate some statistic based on which it can draw some inferences between the classes of the data or different classes of the data or some other higher order statistical properties. The main things involved in unsupervised learning methods are like clustering, dimensionality reduction, and many other things. But in very specific for unsupervised deep learning techniques, there are few methods which we'll be discussing in a later slide. And third paradigm is reinforcement learning. Reinforcement learning is an entirely different paradigm in which the agent and the environments are involved. The agent tries to interact with an environment and then learn from its trial and error, learns in a trial and error basis. Okay, let's give an example of how supervised deep learning models look like. Okay, here we're talking about one specific deep learning model known as convolutional neural network. Here the feature extractor is a CNN, a convolutional neural network, and a classification unit is an MLP, or a fully connected multi-layer perceptron network. Okay, here the input for a CNN network is a two-dimensional matrix or a tensor, and then there are weight sharing. There's a weight sharing involved where these weight parameters are convolved with an input image, and then we obtain a feature maps, apply a max pooling, apply a nonlinear activation function, and then do a max pooling, and similarly we get repeat the same process and we get convolutional features, and then flatten out these features, apply a classification layer, and then we add a softmax distribution to get a probability of each class, and based on this probability distribution we say what class that input image belongs to. Suppose in this case the given image is car, so the probability associated with this car will be very high as compared to any other truck, van, or bicycle. This is a supervised learning as a whole. You have an input data, and you have a target vector given. Okay, beyond classification, what else is there in supervised deep learning methods? Okay, we have semantic segmentation, we have instance level segmentation, we have object detection, object localization, image captioning, and many other things. Okay, what is semantic segmentation? Semantic segmentation is again a classification problem. Here the classification is done not on the basis of an image, it's done per pixel. It's done based on per pixel. In this case there are 4 different classes. Each and every pixel in an image belongs to one of these classes. So this is sky, this is some hills, and this is grass, and this is cat. If I say what this pixel, which class does this pixel belong to, the network will say it as a belongs to the cat class, and this is how the semantic level segmentation is performed. Okay, so object detection, we have an image, we have multiple objects in the same image, and the task is to detect each and every object in an image. In this example there are dogs, kitten, and a duck, which can be seen, like which are marked, annotated, and detected in this algorithm, deep learning algorithm. Image captioning technique. Image captioning is basically to make sense out of the image. For example, in this case we can see that the cat is on the grass, and that's what the network has been predicted. Okay, yeah, what are unsupervised deep learning models, and what types of unsupervised deep learning models do exist? Okay, there are a few unsupervised deep learning techniques. Few of them are restricted Boltzmann machine, deep belief networks, deep Boltzmann machines, and generative adversarial neural networks. Few other which are not included here are variational autoencoders, convolutional autoencoders, and more. What are these techniques? Okay, let's discuss what is VAE in the broad picture. VAE is like we have a non-linear function approximator which downsamples an image or encodes an image to some n-dimensional feature space, and then from there we'll learn some probability distribution properties, and from that distribution again a feature vector is sampled, and then that feature vector is sent to a decoder part where the image is reconstructed, and then this error is calculated between these two images and the feature dimension, like this lower dimensional feature vector. Based on this error, the whole idea is to produce or generate images which is very similar to that of an input image with slight variations. Similar idea is for GANs. GANs, we have a neural network black box which tries to spit out or generate images of any given dataset, of any given class, whatever it's trained on. Similarly, in case of deep Boltzmann machine and our restricted Boltzmann machines, the idea is to make sense of an entire environment using a limited amount of data, or entire data set using a limited amount of annotations or limited amount of data. In the case of deep belief networks, it's again a repeated Boltzmann machine. Like in the case of deep networks, it is a deep network with like undirected graph where the error can flow both the ways, and it helps us when we have a low amount of data or less amount of data, and it helps us to generalize the data very well. Okay, we have like what is learning? I'm talking about learning since like last few slides, but what actually is learning? Okay, learning is the weight convergence of the weight or the updation of the weight according to the data. For example, learning can be associated with the optimization, and the most important algorithm or one of the backbone of a deep learning techniques is gradient descent algorithm. The more details about this convex optimization and gradient descent are shown in the link below in the description. Please do check them. What is this algorithm? Algorithm is we initialize a neural network randomly from some distribution, and we have some for loop which is infinitely looped till convergence, and we compute the error, and based on that error we compute the gradient, and using that gradient we update the weights. And this step where the weights are updated according to the error, gradient of the error, is termed to be a learning process. How do they learn? Suppose we have a weights wx, and this wx is a old weight and star wx is a new weight. We obtain new weights by taking old weights and subtracting some factor into the gradient of that weight with respect to gradient with respect to the loss. No, gradient of the loss with respect to that specific weight. Okay, this is called as an update rule in deep learning. Some common error functions, or the error which you see here, basically says how far or how close your predicted target and actual target is in some n-dimensional feature space. Most commonly used error functions are MSE error, MAE, binary cross entropy, and cross entropy. MSE for regression, MAE when you have an outlier detection kind of problem, binary cross entropy and cross entropy are used for classification problems. Okay, let's see the deep learning in action. These are few experiments which I have conducted using deep learning models. This one is using Masca CNN, where the task is to segment out the vehicles coming in between. The task is to segment out the vehicles coming in between and classify them. You can see that each and every cars are getting segmented out with a probability greater than 95, sometimes 72, and more. And this is another work which is semantic level segmentation. The aim is to classify the different regions of the tumors in a brain. This is the actual input image, and this is the ground truth image. This is a network prediction, and this is after post processing. And in this case, it's a robotic surgery. We need to classify or again perform a semantic level segmentation on multiple classes of kidney and the robotic organs, robotic arms. This is an input image, and this is a model prediction after CRF. CRF is a conditional random field which is part of the post processing, which we'll be discussing in upcoming videos in the series. And again input image and a corresponding weight. Okay, thank you. I hope you like this video, and please do check the links in the description and this website if you are interested in some biomedical projects or in deep learning